Hi, Oslo. Hello, world. Let's code an incremental source generator with Roslyn. Today, the next 60 hours, 60, why? 60 minutes, we will learn about what source generators are, where they are in use, they definitely came to stay, they will not go away, and how we can build one ourselves. My name is Stefan Pölz. I'm from Austria. I love .NET and C#. I started with Roslyn, actually, when the pandemic started. Then with source generators, I started when they got actually released, together with .NET 5. And currently, I'm a senior software developer at Trayport in Vienna. I also have a Twitch and YouTube stream. I'm currently also streaming about Roslyn. That's my hammer, and every problem that I have is a nail. I am a co-organizer of the .NET meetup in Vienna, a Microsoft MVP, and a JetBrains community contributor, where the latter may come in handy to you if you take a picture of the stage or in the overflow room of the screen and either tweet it and tag me with @0x_f0 or send it via Twitter, Mastodon, or LinkedIn as a private message. Then I will raffle 2 JetBrains Wider licenses at the end of this day. So what is Roslyn? Roslyn is the open source compiler platform for .NET, and it supports both the C# and the Visual Basic programming languages. Who of you has used Roslyn or something with Roslyn, maybe an analyzer or a code fix provider, consciously already? See, a third of the room. Who of you has used a source generator in particular already? Okay, like 10 hands roughly. And who has built already a source generator? There's 1, 2, 3, okay, 4. I hope that we have quite a spread in the experience level with Roslyn and source generators. I hope that I have a takeaway for all of you. And after the session, please let me know if I delivered by voting for the session. So in Roslyn, this is a compiler as a platform. We can write our own plugins, such as an analyzer, which produces squigglies, warnings, and errors, and also a code fix provider, where we then can either Alt-Enter or Control-Dot this diagnostic, and we get fixes suggested, such as using newer language features. Wider does this a lot. And with Roslyn 3.8, which got shipped in .NET 5 SDK, we also got source generators, and with .NET 6, incremental source generators. What the difference is, we will find out in the next minutes. So, source generators got released with .NET 5, and with .NET 6 and .NET 7, Microsoft is also building source generators and supplying them as part of the .NET framework. So when we target .NET 6 or .NET 7, we get the source generators out of the box. For example, system text JSON source generator, one for logging. This is, if you have seen the talk from Nick Chapsas yesterday about logging, he showed this as well. And in .NET 7, there's actually 3 more, I missed one, a regex generator, an interop generator, and also a JavaScript interop generator. And .NET 8 will have more generators coming because, let's go there. Because they have very specific, the use cases. Let's go to examples first. So how could a source generator look like? Let's actually take a look at the logging source generator. So I'm having here a benchmark. I'm using the, sorry, I forgot to launch the tool. I have here the standard extension methods logging that we have logger.information. We put in a message and the parameters. But this has a bit of a problem because this params array, this params array here is actually an object array. And not only do we allocate an array here implicitly by the C# compiler, but also if we have value types, such as this number here, this is an integer, we box them to a reference type, to the object, which means we have additional heap allocations, which causes pressure on the garbage collector. And with a source generator, can produce very specific source code for our need here to avoid these allocations. And how this works is we create ourselves a new type, we make it partial so that the source generator can add new sources to it, and we define now our partial method. In previous rules, before C#9, we couldn't have an accessibility modifier on partial methods. We needed to write partial methods like this. When we add the partial modifier, now the new C#9 rules apply. And they mean we need to have an implementation. If there is no implementation, this won't compile. With previous, without the accessibility modifier, extension methods had to be void. They couldn't return anything. That means if there is no implementation, then the call to this method actually will be stripped out of the compilation. But when we do apply the new rules, there has to be an implementation, but a lot of limitations have been relaxed. And we do need an implementation, but where is this coming from? I didn't write this. So if I go to the implementation via F12 here, we see we are now in a generated file. They usually get marked, the file name, it's not a file name, this file doesn't really exist, it's a hint for tooling. It's suffixed with .g.cs. It would also be .generated.cs, which is a marker for tooling, for example, for Rider or Visual Studio or Roslyn analyzers, that this is a generated file and the user has no direct influence of how this is generated or how this file is written. We also have the auto-generate content comment on top of the file, which is a further indicator this is generated. And now this creates this logger message.define has been available previously already, but it's rather tedious to set up. And this is now what the source generator takes from us, and it implements automatically, and now has strongly typed overloads. So we don't have this array allocation anymore from the params array, and we have no boxing. And this shows in benchmarking. So if we compare, actually in the benchmark I also log with a minimal version, with a minimal log level. So if we actually, if the logger is, okay, sorry, because we log here in an information. But if we set the minimum level to warning, then this information isn't logged. And in this example, when I set to warning, then we actually don't log anything, but still in the standard extension method approach, we still have this allocation. And now with the source generated version, here's the source generated version, we don't have this allocation anymore. And it's also significantly faster because we avoid those allocations. Another use case is to avoid tedious implementations. For example, in XAML-based applications. I have here a very basic application where I want to bind a number and want to have two commands, an increment and a decrement command. And which, when you have a look at the code behind, or at the view model implementation, we actually don't implement this iNotify property changed anywhere, and we don't define our commands and such, which is always the same pattern, it always looks the same, but we still have to do it because this is how the plumbing works under the hood. But where the MVVM toolkit source generators that are available as a NuGet package from the MVVM from the community toolkit, this can now be all generated. So let's run the application briefly. Now we have the increment and decrement functionality without us actually writing this iProperty notify changed and the commands. And the source generator is actually producing this. Now the experience is very similar in Visual Studio. We can go to our dependencies, then find the source generators here, and here we can see, okay, now the source generators from the MVVM toolkit are kicking in, and we can see the documents that they create. They are not necessarily files. The source generator files are not necessarily put to disk. There is a compiler flag that you can set if you want to have them potentially checked in a source as well to get a diff. But by default, they are not really on disk. So it's not files, it's documents. And again, here they are. Now they are marked via .g.cs and the auto-generated comment. And here's now the implementation, the property notify changed implementation. So all the code that we didn't have to write ourselves. And the third use case is that all of this facilitates trimming and native AOT. So the last example is the JSON serializer that got shipped with .NET 7 and improved in .NET, shipped with .NET 6 and improved in .NET 7. Now, what I'm having here is, again, a partial class that derives from the JSON serializer context. And as an attribute, I define which type that this serializer context should be able to serialize and deserialize. I can also set options. For example, I want to have it indented. And again, if we go to the implementation, I didn't write anything, I only have the partial file. But with these attributes, the source generator creates a lot of code and very specific serialization and deserialization, and strongly typed. And there is no reflection, because the default implementation, if we use serialize and deserialize without the source generated version, what system text JSON does under the hood, because there is reflection involved, and reflection is expensive. So what they do is, when the very first time you serialize and or deserialize an object of a specific type, the system text JSON serializer is emitting via reflection.emit new IL code that is compiled once and then reused. So it's creating a special case implementation at runtime, which is the problem. It's at runtime. And in native AOT scenarios where we don't have the JIT compiler, we can't do reflection emit. And now if we do this, if we shift this creation of this object from runtime to compile time, now this is AOT friendly, because there is no need for the JIT, because the Roslyn compiler is already taking care of that. And it's also very nice for trimming, because we don't have any unreferenced code, no dynamic code emitted. So the compiler knows exactly what code is invoked, and our application keeps trimming friendly. Okay, I haven't explained what trimming is. This is a rather new concept. If you have a self-deployed application, usually they are rather big, because you have the entire the .NET runtime, all of the BCL included. And with trimming, the linker goes in and sees which methods and with which types and methods are not used, are not referenced by any code, and removes them, so that the final binary is becoming smaller. And so we can have smaller self-contained applications. And native AOT is a new approach where we don't have the JIT compiler. So everything is compiled for a specific platform. For example, in my case, it would be Windows 64. And directly to machine code. So there is no JIT anymore. So the startup performance of the applications is very fast. And this is very suitable for serverless applications like Azure Functions or AWS Lambda, because we save a lot of this cold startup time. And this is another use case where source generators come in handy, and there will be more and more of them. So what are the laws of source generation? We retrieve the input to a source generator is the compilation. The compilation is basically all of the source code and its dependencies of the project. And this is represented with syntax trees and the semantic model. What does a syntax tree look like? If we go to sharplab.io, we can enter some code, and then, well, the default is the C# version, so it actually compiles and decompiles the code, so it basically gets rid of all the syntactic sugar. And we can also change it to the syntax tree, which is now the Roslyn representation of our source code. it's now a tree which has nodes and tokens and trivia, where a node has children, tokens are terminal, they are leaf nodes, and trivia is something that has no influence on the compilation, something that is not part of the IIL code, such as comments. We don't find comments in the IIL code. So at the top, we have a compilation unit, which is basically this entire document. Then we have a using directive. Now this using directive consists of a using keyword. It has an identifier name. If we drill down to this identifier name, which is a node, now this has a token system. Then we have a class declaration. We could also have a struct declaration or an interface declaration. And again, we see all the keywords that we have in use here. Public class are represented here in the tokenified version of our source code as well. And there is a method declaration. This method declaration, it has a return type. Now this return type is a predefined type. Predefined types are language types, such as void, int, double. Again, an identifier. Identifiers are always these that basically we can then invoke in our source code. And also, where is our trivia? I think, let's put a comment on top to also see, here is a comment that is a single line comment trivia. You can also have multi-line comment trivia or preprocessor directives. The #if is also trivia. And this tree is now the input to the source generator, and we can analyze this tree, detect patterns, for example, this attribute, now the JSON generator, would search for all partial classes that are attributed with this attribute, then drills down into the type that is used in here, and then inspects, then basically goes to the type, understands that this type has two properties, a string and an int property, and generates the special case serialization code at compile time for us. And this is the syntax tree. What is the semantic model? The semantic model now gives meaning to our source code. My favorite example here is, what if we could return, let's say, an int 32 here. Let's return 1. But what if I, in the same compilation, now define my own type? Let's also make it a struct, int 32. Now we already get this doesn't compile anymore, because now it's actually our int 32 and not the system int 32. If I want to avoid this confusion, I could go to the global namespace alias, and now here have again the .NET standard int 32. I need to write system, of course. And now the compiler warning disappears. And this is where the semantic information comes in. From a syntax view, those are both int 32 that could live also, if I would put this in a system namespace, then from a syntactic point, I couldn't really differentiate them. But via the semantic model, now the semantic model actually gives meaning to these types. And I know now via the semantic model, okay, this is the BCL int 32 that is equivalent to the int keyword. And this is some other struct, which is empty. It has no members, so they don't match. And with this input, the source generator can then analyze it and produce new code. It's a string that is produced. We can produce 0 or an infinite amount of new strings. Each of those strings is then a new document that we should suffix with .g.cs, so the tooling knows it's a generated file. And this really is a string. We will see this later with the live example. Source generators are additive only. They can only add new source. This is no aspect-oriented programming model where we can actually replace or delete code during compilation. This is currently not possible. There is potentially something in a smaller scope coming up with .NET 8 in preview, something like interceptors, where we can have a bit of an influence at the flow, but it will never be real replacement. source generators are analyzers, technically, so they can also produce diagnostics. We shouldn't. We should actually use a proper analyzer, diagnostic analyzer, but I come to the why at the end. But technically, it's very possible. And the source generator can also look at additional files. In our compilation, I have, for example, here an example where we have some additional text. And if we mark this additional text as additional file in our compilation, now the source generator could see this as well. And with that, we could basically build a transpiler from JSON to C# if we wish. Or we could also put some configuration in these files that we then recognize. Source generators are unordered, so we don't know in which order they run. If we have 7 source generators in our project, all of these 7 source generators get the same input. They cannot depend on each other. That means they are oblivious. And I already mentioned they're technically analyzers. Right, from the language perspective, in C#2 we got the partial types, and in C#3 we then got partial methods. I already mentioned this; they could only be returned void. But with C#9, this is basically support for source generators. We can now have more powerful partial methods, and I think all of the Microsoft source generators are actually based on some partial model. So I create a file and create a method. I attribute it with an attribute, and then this partial method will be implemented by the generator. And in C#11, we have also file-scoped types. This helps also with generators, because if the generator creates a type that I already created manually as well, then I have the same name and the same namespace, and this is a ambiguity. So in order to avoid that, I could make some of my types which clash with the generator as file type, and then, although they have the same name, they won't clash anymore. Okay, now let's get into building a source generator. The example that I would like to show is enum is defined. So we have, actually, let's go to the benchmarks. What we have here is basically a version, the BCL version of is defined. In .NET Framework, this wasn't generic yet, but in .NET Core, .NET 7 that I'm using here, it's also there's a generic overload of it. And the is defined has a bit of a performance implication, because under the hood, it does reflection, again, to inspect this enum and then give us the information whether the type, the constant that we give in is actually defined. And I think it caches it then in an array, and then does a binary search on that. And for smaller sized enums, this is not the fastest. So an actual faster version would be if we would hand roll it ourselves. If we just have, for this log level, that's the Microsoft extensions logging log level type, where we have our 7 constants. We could basically define it ourselves and say, if this value give in is any of these, then it is defined. Otherwise, it's not. But this manual implementation is, yeah, it's tedious. I know ahead of time exactly what I'm going to be writing. If I would implement this for a different enum, it would look like it would look exactly the same, or it had the same logic of just iterating through all the checking all the constants. And if a new value to this log level would be added, I must not forget to actually add it to my manual implementation as well. And this is a bit tedious and also a bit of a maintenance. Well, hell is a bit of an overstatement, but a maintenance risk. And now this is a super example of a source generator, because I already know ahead of time what I should generate, and basically it's this as a string. So the example that I would like to have is, again, we define a partial partial type, where the source generator then can add methods in. And we attribute this with the isEnum defined attribute. This is a C#11 attribute. It's actually a generic attribute with the enum type. So we constrain this. This must be an enum. And then the source generator can kick in and generate code for that. Now I like testing, especially when starting a generator and then it gets bigger and bigger. It's, from my experience, really, really helpful to have a suite of tests to not break previously working scenarios. And there is a package from Microsoft which is called, I'm in the wrong project, right? Yes, there it is. Which is called microsoft.codeanalysis.c#.sourcegenerators.testing.mstest. So what we see here is, because the source generators are the compiler platform for both C# and Visual Basic, we could also write the source generator for Visual Basic. F# we can't, because F# is not using Roslyn. And there is an MSTest implementation of this testing framework. We could also select XUnit. There's also packages for XUnit and NUnit. And with this package, we can now define our tests. And what we see, there is a lot of strings. I'm using raw string literals here. I really, really like them, especially for testing Roslyn-related code. I have here an input. It is this attribute that we saw. I also want to generate this attribute at compile time. And this is actually a nice feature from Rider if we enable syntax inspections. I believe. Then Rider actually renders this C# code, because I put here, I think it's called language injections, actually renders this string via as C# syntax. But even without this highlighting in other IDEs, I really like the raw string literals, because we can really nicely format our C# code. And I have one test where if we have a partial type, but there is no attribute on it, the source generator shouldn't generate anything. It should only generate the attribute, which we verify here. This isEnum defined attribute.g.cs should be generated as this string. Then we have another test where we actually have the attribute on this partial type. And then we expect actually this method to be created. So we add another partial class enum_info, which should have the name of the class where the attribute is on. This is now all. We will get this all with the syntactic information. And then we create an isDefined method and return this condition to see is it any of this string comparison constants. Now what we do here is we always refer to the global identifier, to the global namespace alias. This is because what if the user defines their own system string comparison? Then the source generator could create code that again has a violation, and then it wouldn't compile. We must be very careful that our source generator creates code that is compilable. Because in the pipeline, now the first step is we get the code of the user, the compilation of the user. Then this gets fed in to the source generator. The source generator now may or may not add multiple additional documents. And then all of those documents are compiled again as one. And this is then the final result that will be produced. So if I have an error or I cause an ambiguity in one of those generated files, this entire compilation will fail. So it's always good habit to refer to the global namespace alias. And it's also always good style to add the auto-generated comment on top of the file, so that tooling, for example, under other analyzers, understand this is a generated file. I shouldn't really produce warnings on that file, because the user doesn't really have influence on this file. It's generated by a generator that he or she may not own. And then we expect that this isEnumDefined.g.cs file is generated. And also a bit of a corner case. What if the user defines multiple, oh no, this is a different example. Interesting example is where the user defines a class in the global namespace. We need special attribution for that because we can't then put it into a namespace. And again, we expect then the according code to be generated. And also, if we have a enum, in this very case, if it's empty, then we just return false. So now let's get into the anatomy of our generator. The package that we will be consuming is microsoft.codeanalysis.c#.workspaces. I think in this example, I'm actually not using the workspaces part. There's also a package which is microsoft.codeanalysis.c#, which contains the syntactic and semantic models for C# and also the base classes for the base interfaces for the source generators. Also, there is a microsoft.codeanalysis.analyzers package that I always like to add because it has warnings and infos about how to use Roslyn correctly, especially when it comes to equality. There are some potential pitfalls there. Now, I'm doing multi-targeting here. This is not really a supported scenario. Source generators and all other Roslyn components, analyzers and such, they currently all must implement Net Standard 2.0. This is because of tooling. For example, Wider, the backend of Wider is, I think, on .NET 7, but Visual Studio is still on .NET Framework. So we can't use any .NET Core libraries. It must be .NET Standard 2.0. I still do multi-targeting here in order to get nullable annotations, because the .NET Standard 2.0 reference assemblies, they are not annotated with nullable annotations yet, but I still like nullability warnings if I make some mistakes, and this is how I enable them. There's a bit of advanced, not supported scenarios, but in case it is very helpful to avoid null errors, because generators should not crash. And then we start with implementing this interface here. But this is already the newer interface. How many of you do know the site source.net? I see a couple of hands. This is the source code browser for the BCL, the base class library, where we, for example, can find a value provider. Not value provider, time provider, which is a new abstraction that is coming up in .NET 8. And the same thing exists also for the Roslyn source code, which is source.roslyn.io. By the way, all the resources and links I have, they are in the presentation if you want to check them out later. And in source.roslyn.io, we can find the interface iSource generator. And this iSource generator interface is the one that has been added with .NET 5. And this is actually now considered deprecated because it has a bit of a performance pitfall at some certain sizes. I will come to that later. The newer version that we should use is the incremental version, incremental generator. And we will find out what the incrementability about that is at the end of our example. So we will start with implementing this interface. And we also put the type, the attribute generator on top of this file so that tooling, such as Roslyn tooling, the IDE or the .NET SDK knows, okay, this is a generator, this is important as part of the compilation. And well, I said in the beginning that source generators are unordered and they cannot depend on each other. There is a little bit of a wiggle room there. Let's have a look at the versioning. If I, oh, right, I have that here. No, oops. No. So here are all the versions that of Roslyn that have been, or of Roslyn with source generator functionality have been created. So it started with Roslyn 3.8, which is part of the .NET 5 SDK, and this added the source generators. Now with 3.9, we got this concept called register for post-initialization. And post-initialization is a step just before the other step. So what we now have is we have our input, and the compiler now has the chance of creating some code unconditionally, where the generator doesn't have the user's code as an input yet. So we can create some code unconditionally. For example, this attribute. I always want to emit it, so this is a good candidate for that. And then in a second step, we can emit conditional files that are based on the user's code. And this step, where we create the second set of documents, actually sees what we create in this post-initialization. So we have two steps. And other generators, so if other generators can see the code that is generated by post-initialization from other generators as well. So first, all the post-initialization from all the 7 generators we have in our project are executed, and then the general execution. And here is now the new version in 4.0.1, which got shipped with the .NET 6.0 SDK. We have added incremental generators. I also list the tooling, Visual Studio and Rider, and Visual Studio Code, which support all of these versions, if you want to refer to this later. There it is. So now we have the base of our generator defined, and the compiler during compilation can actually use it and call into it. And at the first step, we do this register for post-initialization. And in this post-initialization, we create this attribute. I created in the Roslyn.generated namespace, and it also has the generated code attribute. So it's also good practice. There's a lot of best practices of how to generate code, to put the generated code attribute on top of members and types that you generate, so that again tooling knows that this is a generated file, or this is generated code, because the auto-generated comment is good for Roslyn-based tools, because Roslyn gets also that's a comment trivia as an input. But if we build for example, an MS Build extension that is based on an already compiled version of the code, this attribute isn't there anymore. And these tools, so that these tools can also understand what generated code is, it's good practice to slap the generated code attribute on top of these types and members as well. So now we have this attribute and can actually use it. If we jump to the example, we can actually use this attribute, this generated attribute. Here it is in our example. And now we need to build up our pipeline. With the incremental generators, we build a pipeline of, first we get an input, for example, the source code, or also the input could be additional files, like a JSON file that we want to create, that we want to transpile into C# code. And then select the interesting parts. We filter the interesting parts for us, and then from that information create a string that is the new document that we want to emit. So let's again go to SharpLab in order to know what we want to search for. In our example, we have a partial class. I call it my class, which has an attribute on it. So we also, let's omit the attribute, it also has an attribute. And this is what we need to search for. This my class is a so-called class declaration. So we get all of the nodes and tokens that we see, all of the nodes that we see here get as an input to the generator. So we need to filter all of the class declarations that also have the partial keyword. Because if they don't have the partial keyword, the source generator can't extend, under air quotes, this type. So let's go find all of these. And we do this via the syntax provider. The name is rather revealing. It provides us the syntax information of the user's source code. There is many more providers. There is, for example, a compilation provider, which contains then semantic information. We also have the additional text provider that we saw earlier. This could be the XML or JSON file. We also can get a hold of the parse options. This contains, for example, information with which language version, which is it Visual Basic or C#, and which version, in our case, C# 11, is this code compiled. So we then create this is actually a new type. This for attribute with metadata name has been added in, I need to go cheat, has been added in 4.3.1. This is the 6.0.4 SDK. And actually, the version from Roslyn that we consume is significant, because that also marks the minimum required SDK version so that the user can actually consume these source generators. So in our case, we need at least the 6.0.4 SDK. If I use a higher version, for example, version 4.4.0, we would require at least .NET 7 SDK. So be mindful about how many features of generators you want to use, and also which is the minimum SDK requirement for your consumers. And with this new version, we can actually, it's very simple now to find syntaxes that actually have an attribute on top. So in our case, we get every type that has this attribute as a metadata name. In metadata name, since we have a generic attribute, I'm sure you've seen this already in some debug output. When we have a generic method, a generic type, it's actually we have at the end a backtick and then the number of generic type parameters, the type arguments that this type has. So in metadata, this is the name of our attribute. And we pass this into our for attribute with metadata name. And then we have a lambda, a predicate. This predicate returns true for every node that we are interested in. So we get in all of the syntax nodes. So we get in the entire compilation unit, the using directive, and the class declaration. And this is the one that we wanna filter. So let's search these. Let's get a hold of the node and say, is this a class declaration syntax? And we also want to know if this class declaration syntax, so let's say syntax, has a partial modifier. These keywords here, they are called modifiers. So we can get a hold of the modifiers list and say, do we have any syntax kind that is partial? The partial keyword, there it is. And this now returns only true for all the class nodes that has that are partial and also have this attribute on top, or at least one of these attributes. We could also have multiple. It requires at least one. And then we have a transform. So we can now extract the information that we need. So via this context, we get the information from the predicate that we have before. So we do get the target node. The target node is our class information. So let's extract that, because that's actually the base syntax node, but we can safely cast it because we did our type check up here already. So this will be our class declaration. Class declaration syntax. And we also want to get the symbol information behind it, because we require the symbol information in order to get a hold of this type that we refer to, because we then need to inspect this log level type and understand all of the constants that are defined at this type. So we will also get a hold of the symbol. And we know, in this case, I know it's an I named type symbol. It's a symbol that also has a name. And we get this in the context dot target symbol. So there's not the symbolic information, the semantic information of the class which has this attribute. And I put this now here in a value tuple so that the next step has this as an input. And additionally, also the attribute data, so that we can extract the information out of that. In the respect of time, I have implemented the rest of the pipeline already, so let's go through the rest of the pipeline. I'm using immutable array here to create lists, because that fits the Roslyn programming model. In Roslyn, you won't find any public list usages, because in Roslyn, everything is immutable. That is so that different compilations can run in parallel. The entire syntax tree is immutable. And I want to fit that model and use the immutable versions of the collections as well. So what I'm basically doing here is, because we could have multiple attributes at a class. I think I have this example. I had this example in the unit tests. So we extract all of them in a select many. This is very similar to link, but it's actually not link. So on the syntax providers that we have, the pipeline that we built, we have transformations. We can select which has the semantics of the link select, but it isn't actually link. It's a new implementation from the generators. And we can also collect. That means if we have a collection, if we have multiple matches, we can break this down to a single one. So basically convert it from an IEnumerable to an immutable array. And after that, we now need to get all the information out of those symbols and those syntaxes, because this will come in handy later. The incremental source generators, due to their incrementality, they allow memorization of several steps. And this memorization doesn't work well on the Roslyn types, because they are immutable and they are in a tree. We can't really say that if we get in the same compilation again, we can't really say, is this now a different class or not? So the equality doesn't really work on these Roslyn types very well. So we need to extract these into information that is very nicely equatable. For example, string information. So what we're doing here, we're getting the attribute data and filtering this now. I have here an enum. There is enum defined info. This is just a custom record which now holds all of the information. We get the Boolean, is this type that we found, is this class in the global namespace? And also we get the name of the namespace. We get the name of the class via the symbolic information. We also get and now we get all of the members. But we again need to filter them, because while building this generator, I actually learned that enums also have a constructor. So we can write, if we have the log level here, we could write a new log level. Every enum also has a default constructor. So we need to filter that one out. Oops. And we do that by, we get all of the members of this type. We want to find, and this is now the filter, we want to find all of the fields. And this now includes the constructor. And then we basically are good to go and have the final step in the pipeline. The final step is the register source output. This is then what actually creates the documents and the strings. So there is various methods how you can assemble this string, I'm using a string builder here and wrapping it in an indented text writer because you can do nice indentation with that. And basically now create line by line the document for the compiler then to compile. So we start with an attribute. I also like to always enable nullable annotations for these documents. Then we go through all of the enum infos, and per enum info, we create a new namespace if it is in the global namespace. So this is very relevant because otherwise we would get compiler errors. If we would try to access the namespace, if it's in a no global namespace, then I think this is some unspeakable name which won't compile. Then we create, this is the extension point, the partial class, and then we emit the method that we want to create. With the enum type that we have put in the attribute. Then we want to understand, hey, do we have any constants in this enum? If not, we return false. Otherwise, again, line by line, we create this switch expression. And here we do some indentation to format this nicely. And then we close all the braces again. And at the very end, we then call the method add source. This is then what really adds this code to the compilation, and we give it a name .g.cs. And now we actually have this enum info generated by our source generator. And again, yeah, this is now basically the very same version as the hand-rolled version, but if we would add a new enum, then this would get added automatically. I think I have do I have a test for that? I believe no, I do not. But we could add like another one. Let's say let's create our own enum, public enum mine. Let's have a first. Let's use this mine here. Now we should also create. There it is. This is defined here. And when we add another one, while I type, now the new one gets created. We can actually see this nicely side by side. Just as I type, now the source generator kicks in and soon adds this new enum to it. And when I start removing one, the second one will disappear momentarily. And the cool thing is that in the source generator version, because it's just source code that gets emitted by the compiler, we can also add breakpoints. So it's also very debuggable. And now comes the performance pitfall that I mentioned twice already. Because the thing is, let's add in the source code that we generate source.writeLine a datetime.now. Let's build our solution. And let's have a look at the example. Jump to the generated code. And what we see here now is if I change the source code without actually changing anything meaningful for our generator, let's say I add a new line here. Currently we're at 11.14.03. And sorry, I already have the fix in place. I gave it away. So let's remove the fix. There it is. Now we have the expected behavior by 11.40.03, 11.40.35, and I just add a couple of spaces, and this will, when I save, this will be now generated again. but the same version of the source code is generated again. And this is where we could fall off a performance cliff. Because, for example, this is what the .NET team experienced in their in the .NET runtime repo, which is huge. When they add generators, there is a lot of input code. And just by pressing a space, everything gets created, all these generators kick in and generate everything again, which is an incredible waste of resources. And this is now where the incrementality of the incremental source generators kicks in. But it requires this equality that we have mentioned. And we have one little issue in our equality pipeline, because this type that defined here, it's a record struct, so it actually implements equality, but we also have an immutable array. And per default, I think the equals implementation of immutable array checks reference equality of the backed array that it has, which is a new instance, so this will never match. What we actually need is a sequence equal. So what we could do is override equals here in our type, because each and every step in our pipeline that we have built checks the previous invocation via a equality comparer.default, or we can write our own equality comparer. This is what it did here, which is basically just equaling all of the members, and then on the array there's a sequence equal. And we can, after every step of the pipeline, we could add dot with comparer and add our own comparer in, which now means that in the first step, everything gets created anew, and in a subsequent step, is now, if nothing relevant has changed in this enum that we create, in this record that we create as a flow state, then we abort the pipeline halts and doesn't invoke this this new source code again, so it doesn't get emitted. So if I rebuild that and go back to the example, here to the enum info, and currently write 1170.00, and now I remove a couple of spaces, and let's wait a couple of seconds, this will not change. So in the pipeline now, nothing really meaningful has changed because we didn't change anything here, but if we change something meaningful, let's say we remove one of the isEnum defines, now actually something meaningful has changed, and now it actually did remove this one. Now it actually created this output again. And this is the very important part of the incremental generator, so that consumers don't experience in the IDE then a very sluggish, a very delayed experience, and potentially even blocks the UI of the IDE. So the key takeaway with the key point with the incremental generators is that each and every step should rather quickly, or as quickly as possible, go away from the syntax and symbolic information from Roslyn, because they are not nicely equatable, and go to some custom-defined, nicely equality comparable structures, so that this pipeline is aborted as early as possible and we save performance. And if you, in the best practices, I guess we mentioned all of them already, so always put the auto-generated comments and such on top, refer to the global namespace alias in order to avoid name clashes, and so on, and definitely mind the Roslyn version that you use, because that defines the minimum SDK required. I also have a couple of examples in this slide and some additional resources if you want to know more about this. If you go to flashover.net NDC 2023 Gen, this links to this very slide, also with the contact information. If there are some questions I can't answer right now, you can always ask me on any of my socials if you wish, and I try to answer source generator particular and Roslyn general questions. And I guess this now, we have 1 minute for questions. Have I left a question unanswered? Okay, cool. then should I have just hold on. Should I have a question about generators later on? Feel free to contact me and post a picture if you wanna take part in the Champions Writer raffle. And I want to thank you very much for staying a while and listening. Ha det bra. Thank you.